All right, this next section we're looking at is going to be quadrilaterals, review properties of quadrilaterals. So it's going to be N12 right here. Okay, so I wrote some examples for you. All right, so let's take a look at the first one. So you got PT is equal to 12x plus 7, and you have RT is equal to 11x plus 8. Okay, so those are going to be PT, which is going to be this one right there, and RT, which is going to be that one right there. So those should be equal lengths. So that means we can make them equal to each other to solve for our variable x. Okay, so you got 12x plus 7 is equal to 11x plus 8. Let's subtract 11x from both sides. And that's going to be x plus 7 is equal to 8. And then now I'm going to subtract 7 from both sides. That should be x is equal to 1. All right. Our next problem right here, quadrilateral ABCD is a rhombus. So what is measure DAE? All right, so this one, let's actually take a look at this a little bit more. So each diagonal of a rhombus bisects a pair of congruent opposite sides. Okay. So let's look at our example here. So AC is bisecting BAD, so BAD right there. And then we have BD is bisecting ABC, ABC. All right. So in this case, the congruent sides are going to be CBE, ABE, ADE, CDE, BAE, BCE, etc. So specifically ADE, excuse me, is going to be equal to CBE, which is 29. So where's ADE? So we got ADE. So right there, those are going to be equal. They're going to be both be 29. All right. So also since AC and BD are perpendicular, they measure AED. So AED right there is going to be right angle. And ADE is a right triangle right there. Okay. So this means that ADE and DAE are complementary. Set the sums of measure to equal 90 degrees. Okay, so I did here at 29 plus DAE, which is 90. And I gotta subtract 29 from both sides, so that's gonna be DAE is gonna be 61. Okay, so DAE, that one right there, is gonna be equal to 61. Okay, if you add all those up, 61 plus 29 plus 90, that should give you 180 degrees for that triangle right there. Okay, so that's how you'd solve that problem. All right, next one here, we have quadrilateral CDEF is a square. What is the value of Z? Okay, so square, that means they're all going to be equal. Okay, so all sides are congruent, equal lengths. So that means I can figure out what Z is by making one side equal to the other. Okay, so we have 3Z plus 28 is going to be equal to 5Z plus 26. Okay. Subtract 3Z from both sides. That's going to leave me 28 is equal to 2Z plus 26. And then we'll subtract 26 from both sides. That's going to be 2 is equal to 2Z. And then I'm just going to divide both sides by 2. Okay. So those 2's will cancel out. This will become 1. So Z is equal to 1. Okay. Find CF in parallelogram CDEF. Okay, so CF is going to be the top one right here, which is V, which is our our variable. And we know that CF is going to be congruent and equal to DE. So those sides are going to be equal lengths. Okay, so that means I can make them equal to each other. So V is going to be equal to 3V minus 76. So I can subtract V from both sides. So what I do to one side, I do the other, kind of like in yoga. So here we have 3V minus 76, okay, is equal to 0, okay? So I'm going to add 76 to both sides. 76 is equal to 2V, and I'll divide by 2, both sides. Okay, so that'd be V is going to be equal to 76 divided by 2. It's going to give me 38. All right, another one here. Quadrilateral BCDE is a square. What is BD? Okay, so if we know it's a square, then these are all going to be equal as well. So all these are going to be equal. All right, so that means that AD should be equal to BA, okay? Which means that if BA is 35, then what should AD be? Well, it's going to be 35 as well. So that means we're looking for BD, so looking all the way across. 35 times 2, that should give me 70. All right, quadrilateral ABCD is a rhombus. What is measure ACB? ACB. Okay, so we're looking for this one right there. All right, so let's break this down, use some visuals. Since ABCD is a rhombus, the measure BCD, and ADC, the ADC are going to be supplementary. Supplementary means it's going to be equal to 180 degrees. So that means these two add together be 160. So I know that ADC is going to be 64, so I plug that in. And then I'm going to find that my measure BCD is 116, okay, because I subtracted 64 from both sides, okay? So also AC bisects BCD. So that means that we found BCD, so we're going to cut that in half or multiply by half. Okay, so 116 times half, it's going to be 58. Okay, so ACB is going to be 58. Okay, so 58 on this side, 58 on that side right there. All right, one more here. We have quadrilateral DEFG is a rectangle. DF is equal to 12P plus 96, and then EG is equal to 16P plus 64. What is EG? So EG is this one right there. So we're trying to solve for EG, okay? Well, because we have them bisecting each other across, they should be equal lengths. So that means 12P plus 96 is going to be equal to 16P plus 64. Right? Okay. All right, so we can solve for these. So we're going to subtract 12P from both sides. We are left with 96 is equal to 4P plus 64. All right, so we'll subtract 64 from both sides. we're left with 32 is equal to 4p. And then we're just going to check, or excuse me, divide 4 to both sides. So then p is going to be equal to 8. 8 times 4 is p, or is 32. So p is going to be equal to 8, which means I'm going to have to plug it back in here. All right, so back to my original problem. So we have 16p plus 64. Okay. So 16 times 8 plus 64. 16 times 8 is going to be 128 plus 64 is going to give me 192. All right, let's double check it. So 182 EG again should be equal to F or DF. So 192 is going to be equal to 12p plus 96. And now we know that p is equal to 8. So it's going to be 8 times 12 plus 96 is equal to 192. And we have 12 times 8, it's going to give us 96. 96 plus 96 is going to be 192. So that is correct. All right, good luck.